Good morning. Today I'm going to be going over the new objective that we're going to be covering, which is one-dimensional motion. We're first going to be looking at how to calculate the distance that you travel and then the speed. I'm going to be flipping back and forth between two PowerPoints, so let's go ahead and get started. So we're going to be looking at two different types of quantities, vector and scalar. We'll look at those more once we've covered displacement, but first we're going to go over distance. So when you think of distance, you think maybe how far something is traveling or how far it came or how far you have to go to get from one place to another, and that's exactly what distance is. Remember, in the metric system we measure length or distance in meters, kilometers, millimeters, centimeters. Okay, so anything that has the word meter in it, that's the units that we're going to be measuring in. I may give you something in, for example, miles or feet or inches, but I'll usually have you convert to some unit in the metric system. But distance is how far you've traveled, okay, how far it is from one point to the other. Here in this case, okay, I'm giving you an example of somebody moving 10 meters to the right. You can say to the right, you can say east, and then I have them going 5 meters north, or they turned 5 meters and went left. Okay, the total distance that they traveled here would be 15 meters. They started here, they traveled 10 meters, and then they went ahead and traveled another 5 meters. So the total distance there is just 15 meters. All you're doing is you're adding them together. Here's another scenario. So it says you travel 8 meters east, 6 meters north, 2 meters east, and 1 meter south. You go ahead and draw the path that they take, and then you just go ahead and add them together to get the total distance that they traveled. So that's pretty simple. 8 plus 6 plus 2 plus 1 equals a total of 17 meters. So the total distance that somebody would travel if they were taking this path to get from one place to another would be 17 meters. So I think that that's pretty simple to understand. We're not going to look at displacement yet, but again, distance. So distance is just how far you've traveled. You're pretty much just adding up all the distances or lengths that you moved. Okay, now we're going to get into speed. Okay, so speed, when you think of speed, you're probably talking about, or you're using descriptive words. Man, you're going way too fast. Why don't you go ahead and slow down? Or you're going way too slow. Why don't you go ahead and speed up? Those are all descriptive words of speed. Speed is how fast somebody's going. When you get pulled over and you get a ticket, it's probably because you were speeding. Well, what does it mean to speed? What are they talking about when they're saying somebody speeds? How do they know that you're speeding? Speeding is looking at two different factors or two different variables. The two different variables that they're looking at is one, the distance that you're traveling, and two, the amount of time it's taking you to travel that distance. When you're speeding and you get pulled over by a police officer, they're saying that you're covering too much of a distance in a short amount of time. You're moving too quickly. That's what they're saying when you're speeding. Okay. So speed, again, the definition is the distance an object travels in a certain amount of time. The more distance you cover in a shorter amount of time, the faster you're going. The textbook definition is the rate at which an object moves. The formula for calculating speed is distance divided by time. Again, there's two variables here. I'm looking at one, the distance, and two, I'm also looking at the time it takes me to travel that distance or to move that length. Since there are two variables there, the unit for speed, there's going to be two of them. Think about when you get pulled over. They say that you're going 50 miles per hour. Well, there's two units there, miles and hours. They're saying that you are traveling roughly 50 miles every hour. So there's a unit for distance, that would be the mile, and then there's a unit for time. Remember, we don't, which would be the hours. We don't use miles or hours in physics. We use meters, kilometers, centimeters, millimeters, and then for time we use seconds. So again, units, there's always going to be two. Whatever unit you measured the distance in, and then whatever unit you measured the time in. So since there's two variables in the formula, you know that there's going to be two units. In this case, you can have meters per second, or kilometers per second, or centimeters per second, or millimeters per millisecond. Anything that one measures the distance and two measures the time. Okay, so again, units for speed, just remember when you have units for speed, there's always going to be two. Whatever you measured your distance in, and then whatever you measured your time in. If you measured your distance in centimeters and you measured your time in seconds, your speed is going to be centimeters per second. That little slash line means per. Okay, so centimeters per second. Meters per second would be m/s, meters per second, kilometers per hour, km dash, and then hr, so kilometers per hour. So remember, units is very important that you have the correct unit there. So since speed is distance divided by time, you're always going to have 2 units for speed, whatever you measured the distance in and then whatever units you measured the time in. There's different types of speed. You can have a constant speed. The example of that would be like when you're driving in your car and you want to make sure that you're not speeding, you go ahead and you push the kind of autopilot and it'll keep you going the same speed the whole time. So the distance that you're covering, let's say every hour on a trip, is going to be the exact same thing because your speed is not changing. Let's say you push the autopilot at 70 miles per hour. If you drive for 10 hours and you're going on autopilot, that means that every hour you're going to travel 70 miles. Okay, instantaneous speed would be your speed at any given moment in time. Another example of that would be like when you're driving and you look at your speedometer. At that very moment, you're traveling 62 miles per hour. The next second, you might speed up or slow down a little bit, but at that very moment in time, your instantaneous speed is whatever the speedometer says. Okay, average speed. Most of us would have an average speed when we drive. So when you're driving and you don't push the autopilot button, your speed can vary throughout your whole travel or your whole ride that you go. You may be going 75 miles per hour at one point and slow down to 30 and speed back up to 45 miles per hour. So your speed would constantly be changing, but what you would do is you would just get the average of your speed. So you would get the total distance that you traveled versus the total time. So the total distance that you traveled divided by the total time it took you to get there, and that would give you roughly an average speed. Okay. Again, calculating speed. Whoops. So speed is distance divided by time. Remember, distance doesn't necessarily just have to be in meters. It can be in another unit, but if that unit is not in the metric system, you have to convert. And then your time, again, needs to be in seconds. So distance divided by time. You should be able to algebraically manipulate this formula around to solve for the distance or to solve for the time. If you cannot do that, here's the triangle. The triangle is going to help you figure out what the formula is. So again, you cover up what you're looking for. Let's say I'm looking for speed. So I cover up speed and I'm left with distance over time, distance divided by time. If I want to solve for time, I'm left with distance over speed. So my formula would be distance divided by speed. If I want to solve for the distance, I have speed right next to time, so speed times time. So again, the formulas are distance is equal to speed times time. Time is equal to distance divided by speed. And then speed is distance divided by time. So here I have an example. They say that this car is going from one city to another. Throughout their drive, they probably sped up and slowed down. Maybe they even stopped for a little bit. So what you'd be getting here would be their average speed. They're telling you that he's driving a total distance of 150 kilometers in 1.5 hours. So you know the distance that he traveled. You know the time that it took him to travel that distance. So you can plug that into the formula and know his average speed for the trip. So 150 kilometers divided by 1.5 hours, you get a total of 100 kilometers per hour. Again, 2 units for speed, whatever you measure the distance in, and then whatever you measured the time in. Okay, here are some more practice problems for you. So here it says a bicyclist traveling at 22 miles per hour rides a total of 45 miles. How much time did it take? So you're solving for the time. Remember, when you manipulate the formula, your formula for time is now distance divided by the speed. In this case, the total distance that the person traveled was 44 miles, and the speed was 22 miles per hour. So you have your distance divided by your speed. So you have 44 divided by 22, and you get 2. Okay, in this case, you're solving for the time. The time here is in hours. So it would take him 2 hours to travel 44 miles if he kept a speed of 22 miles per hour. Okay, the second example says a mouse is moving in a straight line at a steady speed for 2m/s. Okay, remember this is meters per second for 10 seconds. How far did the mouse travel? Okay, Again, you're solving for the distance. How far are you going? How far is it from one place to another? That's distance. So in this case, you're solving for the D. You have, your formula would be speed times time. So your speed, 2 meters per second, times your time, excuse me, okay, you get a total of 20 meters. Again, you're solving for the distance. Here, look at your units for speed. This was what they measured the distance in. This is what they measured the time in. So the units for distance in this case are measured in meters. So my answer would be 20 meters. Okay, number 3 says the gray wolf is a threatened animal that is native to the United States. A wildlife biologist tracks the gray wolf that moves 250 meters in 100 seconds. Calculate the wolf's speed in meters per second. Again, you're solving for the speed. Speed is distance divided by time. The distance that the wolf traveled was 250 meters, and it took him 100 seconds. That's moving pretty fast. So you have the distance, 250 meters, divided by the time, 100 seconds, and you get 2.5. Don't forget the units. Speed has 2 units, whatever you measure the distance in, and then whatever you measure the time in. So in this case, my answer would be 2.5 meters per second. Here, this last one. It takes Brooke 10 minutes to run 1 mile. What is her speed in miles per minute? Both of these units are not in the metric system, but that's okay because I'm asking you to give me your answer in miles per minute. So in this case, you don't have to convert. If I asked you what is her speed in meters per second, you would need to convert 1 mile to meters, and then you need to convert 10 minutes to seconds. But again, I didn't ask for you to do that here. I'm just wanting for you to solve for the speed. So again, speed is distance divided by time. Her distance was 1 mile. Her time is 10 minutes, so you get 0.1 miles per minute would be her speed. Here's some more practice problems for you to do. Go ahead and work on these on your own, and then if you have any questions, I'll go over these when you come back to class next time I see you. Bye.